Hi, my name is Marcus, and today I'll be talking to you about how I use TinkerCAD and an ESP32 development board to test our hardware design. So TinkerCAD is a web-based program that allows you to create Arduino projects virtually, and I use this to test the Arduino JSON library. So what JSON is a format that you can use for storing data and variables. So if we take a look at the code in TinkerCAD, you can see that I had to include the Arduino JSON library, and I have a bunch of variables for our sensors on the hardware, and we can store those in a JSON format. So you can see this in the serial monitor. Okay, let me show you how to use TinkerCAD. So when I didn't have any hardware, I used TinkerCAD because it lets you simulate Arduino for free, and it's online. So on the right, you can see that there are different parts you can put. So this is just like the ones in real life, but this is virtual. So you can put a breadboard if you want, and I'm going to put an Arduino Uno. So up here, you can see that there is a code button, and then you can choose blocks plus text, or text. But I'm going to pick text. So as you can see here, this is a simple Blink program. So you can simulate it by pressing Start Simulation. And then if you look on the Arduino board to the left, the orange light is blinking. So that's the built-in LED. And you can also look at the serial monitor. If you ever want to print something, it will appear there. So this is a super useful tool to know how to use, because you can simulate Arduino online. Moving on to the ESP32 development board. So right here I have an ESP32 board, and it has a built-in LED, so I'll be using that. So what I did with this is I'm going to test the Arduino PWM library. And what PWM stands for is pulse width modulation. And this can be used for a bunch of applications, but I'm going to be using this to blink and dim the LED. So what PWM lets me do with the LED lights is, normally the light is either completely off or completely on, but what PWM lets me do is change how long it's on. So essentially the light is actually flickering really fast, but to us, we can't see that, so the light is going to appear dim even though it's either on or off. So I'm going to show you two examples of how I use this. So the first one is going to be a simple program that makes the LED blink. So I'll be turning on the LED and turning it off. And in the second example, I'm going to be dimming the LED. So it's going to start completely off, and then it will slowly become brighter and brighter until it's completely on. And then it's going to dim and continue dimming until it is completely off. So like I said before, the light isn't actually dimming, it just appears to be dimming because I'm using PWM to change how often or how long it's on. But keep in mind, this is actually a very short period of time that it's on and off. So you can't see the flickering pretty much. So let's dive into the first example. So in the first example, you can see that I simply created a couple of variables for the LED, the frequency, the channel, and the resolution. And in the setup, I had to set up the channel, frequency, and resolution for the LED, and then attach the pin to the channel. And once the setup is complete, in the loop function, you can see that I use the LEDC write function, which takes the channel and then it turns on or off the LED. The range is 0 to 55. So this is what the Blink program looks like on an ESP32 development board. Okay, moving on to the second example. In the second example, I'll be showing you how I use PWM to dim the LED. So as you can see in the code, the setup is exactly the same. The frequency, the channel, and the resolution and everything. And the pin is also the same. So the difference in this program is inside the loop function. Inside the loop function here, I have two for loops. And these for loops either brighten the LED until it's completely on, or dim the LED until it's completely off. So as you can see here, we use a variable duty cycle, which represents the time that the LED is completely on and the time that the LED is completely off. So like I said, the LED is actually flickering at a rate, but we don't actually see it. It just appears to be dim for us. So let's see what this program looks like on the ESP32 development board. So you can see here that the LED is becoming brighter, and then it's completely on, and then it slowly dims until it's completely off, and then it just keeps on looping. So let's go ahead and see how I use this in the actual code for the hardware. So on the hardware, we actually have 5 LEDs. We have red, green, blue, warm white, and cool white LEDs. So those have different pins and channels. So it's going to be slightly different from the examples. So if we look at setup, you can see here that we set up all 5 LEDs, and then we're also using the same frequency, so it's 5000, and the resolution is going to be 8-bit. And then if we go to the loop function, you can see that we have an LED demo. So the LEDs start all completely off, and then after that, it's going to start fading the LEDs, each one individually. So I actually have a function that fades the LEDs. So the fade function is going to be pretty much the same as the one that was in the examples, the dim examples loop function. So it's going to have 2 for loops that change the duty cycle. And then after the fading of each of the LEDs, the demo is going to rotate the LED lights for the colors of the rainbow. So of course that's going to be red, orange, yellow, green, and blue, and then purple. So after that, after the rainbow, we're going to do warm white and then cool white. And then the last thing we're going to do is rotate through the white color lights. So the white color lights, you can see here that the range is from 2200 to 2500K. And each one of these have different names. So we have amber white, warm white, soft white, natural white, daylight white, bright white, and blue sky light. And then we go from 2200K to 6500K, and then we go back down to 2200K. And then that's the end of the LED demo. Then after that, it's going to continue looping. So as you can see here, you can see that the test on the ESP32 development board is very, very similar to the one that we use on our hardware. Okay, now let's see the code actually running. So I've already uploaded the Arduino code, and I'm going to turn on the LEDs. So as we saw in the code, we started off the loop with all the LEDs off, and then it'll use the fade function to brighten the LEDs until it's completely on. Then it's going to dim them until they're completely off. So we have the 5 LEDs here. So the top one is for red, green, blue, and the bottom LED is for warm white and cool white LEDs. So I'm going to turn on this LED right now. Okay, so right now they're all off, and then now this is warm white, and then it's going to go to cool white. So if you notice here, the light slowly turns on and becoming brighter and brighter until it's completely on, and then it dims slowly until it's completely off. So this is green, and blue. So now we're going to rotate through the colors of the rainbow. So we have red, orange, yellow, green, blue, and purple. Now we're going to rotate through the white color lights. So if you remember in the code, this ranges from 2200K to 6500K, and then back down to 2200K. So after those are done, it's going to continue looping, so it's going to be the same thing again. So now it's going back to the fade function and fading through all 5 LEDs, and that's pretty much it.